mandatory com studies and Carib studies. But I thought that, you know, this would be me. Like this would be my life as of now. This would be my future career, something STEM related, because that's what I chose for Cape. No, using that, I was moving all the way forward into doing neuroscience because by the time I got to sixth form, I never just wanted to be a doctor. I refined that a little and I said I wanted to do neuroscience in particular. I wanted to be a neurosurgeon. So applying for college, I was bent on saying I'm going to go to I'm going to study neuroscience, and that was a whole journey, but that would be a whole story for me to tell, which don't think I have time to tell. Me applying to college, but just know it was difficult. But one thing I was certain of was that I wanted to study neuroscience. That's something I always wanted to do. So I decided to go forward, apply for a degree in neuroscience, and I got into the University of Miami. But when I got in the first semester, things were good. I liked the major that I chose. I liked neuroscience, but then I also realized that there were still a lot of things that I love to do. There are a lot of things that I wanted to do in my spare time that I never really had time to focus on while I was doing CAPE, because believe it or not, CAPE may take up a lot more of your time than, well, at least your first year of college. So it caused me to reflect a lot. And right now, I'm actually very glad I didn't go straight into med school, because I was also considering going straight into med school at UE, but I wanted a chance to actually explore other things. And I'm glad I did, because it was somewhere in my first semester that I realized that while I enjoyed neuroscience, that wasn't the only thing I wanted to do. It was actually one day I had a biology quiz and I'd missed the quiz, and I was really worried that I was not going to do very well in the course, because that quiz took up a good percentage of the grade. So I was really worried. I was saying, Jano, I'm not going to get the A now. Everything's going to be rough. And I was having a really bad day. But I had one class that I'd selected randomly, this creative writing class. And what the class, I had a creative writing in the evening. I had the biology quiz in the morning. So I was early enough for the creative writing class. And when I got to that class, it was still a very rough day for me. I was really down. And then I started just writing about how I felt about that biology exam, how I even felt about biology in general, you know. And yes, people do write about that kind of stuff. And it was actually a big relief for me. And then I realized I've always been writing. Even throughout high school, I would always write poetry. I'd always be writing. Even while I was studying the sciences, I'd really be writing all the time. And that's when I realized that writing was a huge passion for me also. And I remember sitting down with the professor and asking her um, about the major and what are the job opportunities. Because in my head I was like, there's nothing for me really there. There's not going to be any job opportunity. But what I learned is that you don't have to put down one passion because you want to pursue another. It is quite possible to pursue multiple passions and actually use your passions to benefit the greater good. And I still strongly believe in STEM. I did not drop out of STEM. Instead, what I did was I left neuroscience as a major and I started picking up biology, because I also realized that while I enjoyed neuroscience, I really enjoyed biology in general. I loved how broad it was. I didn't want to focus on neuroscience just yet. I still wanted to explore other parts of biology. There were other parts that I really liked. And then I started doing creative writing as a major. And then I also started doing health science because, as somebody who wanted to be a doctor, the human anatomy started to interest me. And it was always a weird mix. I remember telling people, oh, I'm a biology creative writing major, and people would look at me weird, like, how do you mix the STEM and humanities? But I can safely tell you that it's through creative writing, it's through that mixture of STEM and humanities where I was able to achieve a lot of what I was able to achieve. And I can tell you one story in particular. So I always wondered how I was going to use that creative writing major. And I was thinking more long term, because as of now, I was saying I'm definitely not going to be using this major right now. So I wasn't even dreaming of using that major right now. Until one day I was actually in my research lab. And it came down to it that one of the investigators in the research lab, we were doing research on yeast. Because those of you don't know, if you some of you may know what a model organism is. A model organism is basically some animal, some organism that you can take and use it to model humans with. So it's basically an organism you can use and you can run tests on without actually running tests on people, so that you can get results that you get similar in humans on that particular animal. And we were working on yeast in this particular case. And what we're doing is we're actually altering the genes of yeast. And yes, this is something I was doing in my first year of college. We were altering the genes of yeast using this thing called CRISPR-Cas9, which is basically something you use to edit your gene sequences. And by editing the yeast, we could remove potentially harmful genes and see how it affects the yeast without the genes, and see if we add a gene, how it would also affect the yeast. So we're actually looking at genes related to cancer, and the genes that we were looking at in particular, we're looking at IRA2. You don't have to worry about all the complicated names, but basically there's this gene called IRA2. It affects another gene called RAS1, and that has an effect on how cells can develop cancer. And that's what we're doing with yeast. So it was a lot of statistical based data. A lot of us were, struggling to wrap our heads around the numbers and the facts and everything was good until one day the investigator came and said, okay, so now here comes a part that was tough for everybody. This is a hard part for a lot of scientists. We're gonna have to actually write this down, and we're gonna have to actually put this in a way that people can understand. So obviously, and you might be confused by now by all the terminology. I couldn't go in front of people and say, okay, we manipulated IRA2 and then we do this with this gene and that with that gene. People would not understand that. And a lot of the people in my group, a lot of my teammates could not wrap their head around presenting this information in a way that people could understand. But guess what? I was doing a creative writing degree also. So I actually was able to use that creative writing degree. And for a lab book, I literally wrote poems to remind myself of things we did during the day. For the entire semester, I would write poems about each thing we did today. And one thing about poetry and rhyming is that it helps you remember things. So not only was it a fun way of not only was it a way of making the work fun, because working with numbers and working with all kind of genes and remembering stuff, it gets tiring. So not only did it make it fun, but it made it easier for us to remember, because we could just remember that.
Fabrizio, somebody's asking if you did the experiment in your biology course. Daniel.
Oh yes, sorry, I didn't have the chat open. But yes, we did it in our biology course. So actually, at we have this program. It's called the HHMI program. And basically, what that program is that it introduced like incoming students to research that different professors are doing. So for those of you who don't know how the college system may work right now, here at UE and in America also, professors, especially science professors, they don't just teach classes. They're not just teachers. They actually work on their own projects. They actually work in a lab, just like how you'd imagine on TV, them working in a lab, trying to figure out whatever their project is surrounded by. A lot of them are working on cancer at actually, are cancer related projects. So they're professors who actually work in a lab, and as a student you actually have the opportunity to work with them outside of the classroom. But this lab in particular, it actually is a classroom setting, but you're strictly doing experiments. So this was a biology experiment. This was an experiment I did while doing my degree. All I did was sign up for the program. It never took any extra steps. We actually did a whole presentation on it. Um, and there's actually the possibility of getting published. For those of you wondering what publish means, to get published as it relates to the sciences, it's basically when you do an experiment and you write up the experiment the same way you'd write it up in a lab notebook, but a little more formal than that, and you actually present it to other scientists and try and get it approved and try and actually get your work out there as something that you are contributing to the field of science. So Yes, that's something I did in the biology course. We didn't get all the way to being published because that's something that takes years. Like one semester is not enough to get published, but it's a start, and they basically gave us a foot in to research so we can get ourselves, used to biology and the research that it entails. So yes, it was there at UM. And also, so back to what I was saying about me doing creative writing, that actually helped us to be able to write our paper because it came down to it that, hey, we had to write this paper. The thing about a lot of people in STEM is that, and I can say this because I'm also a person in STEM, we're not very good writers all the time. A lot of people in STEM, we don't like writing, we don't like stressing ourselves over anything that have to do with reading or writing unless it's science related. But there comes a time when you have to be able to present, and you have to be able to present your information to people who are not necessarily as sciencey as us. So basically, all that fell on me, and it was through using that love for creative writing that I was actually able to put the sciences for to actually put the science in a way that makes it easier to understand to the regular person. So the aim what I was trying to tell you here is that there are many ways to engage in STEM. If you're here now, chances are you are engaging in something STEM related, but there are many different fields out there. Right now, there's a lot of different courses that we call interdisciplinary courses that actually use several different talents to try and make science more relatable, to try and actually solve real world problems through science. So there's actually a course called Ecosystem Science and Policy at the University of Miami that literally takes people who do sociology, people who do the law side of things, like literal people who want to be lawyers to that degree, and still learn a lot about science, still learn about the ecosystem and how you can help to push forward the values that can help maintain our ecosystem, to help promote the stopping the use of fossil fuels and the harmful things, and actually create legislation that actually protects our wildlife. So what I'm trying to tell you is that there is no one way to do science. Whenever we think of science, we think of the guy in the lab or whatever. And yeah, a lot of the times it's true. Most of science is done in a lab, but there are also people who are working in the lab and people even completely outside of the lab that can contribute to science. So even if you're here and you're still iffy about science, or you even have a passion for the humanities, that doesn't mean you should not explore the passion. There are ways to combine your passions. There's no one way to do science. There's no one way to engage in the scientific community. The scientific community needs writers too. The scientific community needs bloggers. Right now, I volunteer with this brain health initiative. It's called Brain Health Initiative. And all I do for them is I get the facts, any facts or info they have, I collect that, and using what I love doing because I love writing, all I do is write a blog for them almost every other week or so. I just write the blog. That's all I do. That's my one job, just writing the blog. And believe it or not, a lot of the scientists, them don't have time to be writing and sharing because a lot of them are continuously working in the lab. So they don't have the time to, but this is something that needs to be shared. Someone needs to be there to get the information out to people in newspapers, to get them on blogs, to have people to actually have the information so that when you do your Google search, it's out there. Because when you're doing the Google search, a lot of the times it's not the scientists who put up that information. If they were to put up their papers, trust me, if you look up a scientific paper right now, it's going to be really hard, almost impossible to understand unless you're the scientist yourself reading it. So there needs to be people who can present that information. And yes, somebody said in the chat, there are a lot of different people involved in STEM. Yes, there are business people involved in STEM. In fact, uh, looking at from another angle, from the geological perspective. I did a geology class. The professor, he is actually someone who focuses on climate change, and one of his students actually made a lot of money through using what they learned from that class and applying it to techniques to get rid of some of the sublayer, or they're basically layers of matter that are in the earth that can actually contribute to climate change in the future. And basically just goes in and helps to remove a lot of that stuff. and he's making money from it. This is something he learned in a classroom and decided to make money out of it. And it's still STEM related. He's using the science knowledge and he's using it for business. In fact, science and technology right now, if you're keeping up, that's where most of the big business is. If you look at, you know, Tesla and companies like those, Elon Musk, you know, he's not even somebody who really studied much science. He was more of a business person. But guess how he's making the money that he's making? Through science, through technology that pushes Tesla, you know. And for those of you who don't know Tesla, that's the electric car that they're promoting now. So to put a long story short, there are many ways to engage in science. And don't think that you have to be caught up in one box. Don't think that you have to be the stereotypical scientist. Don't think you have to be a doctor or whatever. Being a doctor is fine. Trust me, I still want to be a doctor. I still want to be a neurosurgeon. But I also want to do some research in science. I still want to write. You know, you don't have to let go of your passions. We live in a world where there are a lot of opportunities out there and there are a lot of creative ways to get involved. We have more jobs being created now more than ever. It's not like back in the days where you had to do one thing. Just know that it's a big world out there, and if you stop and look, there are many different roles you can take. You can be an activist for climate change. You can be a blogger. You can be a scientific fiction novelist if you even want to go down that path. Um, and you can be the scientist or the doctor if you so choose. Just be able to identify those passions that you have. Don't be afraid to go after them, and then you'll be able to figure out how you can use those passions to aid STEM and to aid the world at large. Because believe it or not, STEM is the future. Society advances because of science. Science and technology is the reason we have a lot of what we have. Just think about the fact if we never have Zoom, we wouldn't even be able to communicate right now during these times. So that's my main message. And if anybody has any questions, then I'll be sure to answer those. But that's all I really have for you guys today. Thank you guys for having me.
Oh, I would like to say something, sir.
All right, you can go ahead.
At least when you're a doctor, you get to write more.
Could you repeat that?
I said, at least when you're a doctor, you get to write more. Like you get to write prescriptions and all kinds of stuff.
Yeah, exactly. And not just prescriptions. No, there are doctors nowadays who actually spend a lot of time writing because the way medicine is going is that medicine is becoming a field where a lot of the advances are being shared. So I actually know a doctor who works at UA. He writes in, there's this journal of medicine and he writes in it a lot. In fact, this is a worldwide thing and he's one of our very own Jamaican doctors and he writes about epilepsy a lot and a lot of what he finds in his studies. So yeah, like there's a lot of writing involved if that's something you like to do as a doctor.
Sir, my name is Natari. I have a question for you.
Okay, no problem.
So, how does medicine and animation intertwine for you?
Medicine and animation. Okay, that's actually a good one. I like that one. So if you know, I don't know if you know Khan Academy, but Khan Academy is a very popular website.
Oh yes, sir. My sisters play it.
Yeah, like Khan Academy is a very popular website, and you guys may not be. Yes, Khan Academy kids, and there's also Khan Academy also does content for people who want to get into medical school. So there's an exam you do through the American medical school system, MCAT. And basically Khan Academy writes content for that. So there's a team of doctors, there are a team of health professionals who actually use Khan Academy and they work with a whole team of animators to actually come up with the animations for the videos. So there's actually a whole field out there that's using animation, and especially with the way the world is going right now, animations are becoming an important part of how we model things. In fact, in one of the labs that I'm working with, the professor, she actually, a lot of her systems are being designed like her son, he's studying computer science. and he's not really interested in the science part of it, but he is involved in research on the brain because he's the only one who can come up with the program that we use for a lot of what we do. And even in that program, we use animations can be used because there's a way to actually use a model organism without actually using the physical organism. So by creating animations, by creating like 3D concepts, we can actually 3D print things. We can use our animations to make the model organism without actually using a living thing. So we don't have to harm anything, and we can use that to test. Obviously, like, you're going to have to test on a living thing eventually, but animators are very important in that sense. And in this day of content creation, like, there's a lot of space for animators. There's this guy named Dr. Mike on YouTube. He has millions of subscribers, and he's a doctor, like a regular doctor every day, like you'd imagine, but he still does YouTube, has his animations and stuff. So I mean, it's not impossible. I'm looking in the chat. Somebody asked, and thank you guys for the nice comments on the presentation. All right, Daniel asked what made me choose UM. Okay, so actually, what made me choose UM was I was actually torn between two choices because one side of me, I wanted to go to UE and go straight into med school because I wanted to be a doctor. And then I also wanted to study other things that pertain to biology, and especially neuroscience. And here, I couldn't find a neuroscience program here in Jamaica, not for the undergraduate level. Because in America, you have to do an undergraduate degree before you can move on to med school. So there wasn't any neuroscience program here in Jamaica for that. And the type of research I wanted to do, I couldn't necessarily find it here. So I had to choose either going straight into med school or choosing to do what I wanted to do, some of the research before, because I still want to go to med school, but I also wanted time to do other things that I wanted to do. I wanted to be able to do some research before I get to med school, you know, explore some other things. So I actually made a whole list. When I was applying, I was telling myself, if I apply to one school in America, I'm going to apply to a lot of other schools. So the University of Miami actually was my first choice. It was one of I had like 5 schools that I definitely wanted to get into, and Miami was one of them. But in all, I had a list of 20 schools. Like, I literally applied to 20 schools. It was a lot of essay writing, a lot of work, and if you're interested now, I think you guys still have a lot of time, which is good. If you're planning to go to school abroad, that's a whole process, and I'd encourage that as soon as you get to like grade 11, as soon as you get to 5th form, if you're planning on going to 6th form, you start researching, you start reaching out to people. Lenika can give you guys my email if you have any questions about applying abroad if you're there yet. But basically, it's a whole process, and the earlier you start is the better for you. One thing to consider that someone never told me about studying abroad is that they look on your GPA a lot. So for those of you who don't know what your GPA is, it's basically a calculation based on the work you did while at school. So your homework grades, your test grades, everything, they are taken into consideration. So it's not just CSEC or CAPE, they actually consider how you perform overall during the school year. So it's not too late to fix your GPA. So while you can fix it, because I never got that chance to fix it. But why I chose they had a really good neuroscience program. One, it was in Miami, which is very close to home, and the weather is very similar here as it is in Jamaica. And the weather was a factor for me because I don't know about you guys, but I'm not a person who's really a fan of the cold. I don't know if you've been up
Academy
north, but
kids.
it's extremely cold up there. So that was not a thing that
I was
wanted.
born in the cold, so yeah. I'm
Yeah,
actually a
like,
fan of it. I was born in the cold.
me don't know how you manage it, you know, but I could not, I could not. That's not something I wanted to deal with. So those are things you consider when you're choosing, when you want to go on to college. Of course, you guys have some time, but as a long-term consideration, you're going to want to consider what's the type of environment I want to study in. I wanted to study in an environment as close to home as possible, but still had the research that I wanted to do. So for me, research was a big thing. Environment was a thing for me. in terms of opportunities for growth and development, I looked at a lot of the programs they have, and there are a lot of opportunities. So that was something that I also took into consideration. Also, like family, like will you have family members there to support you, because it's hard to make it without family members. If I didn't have family right now, I don't know how I would make it through COVID. So yeah, so those are a lot of factors that affected my choice into UM. William asked a question about curing COVID-19. So yes, actually doctors are the main ones working on the looking for a solution, but we're not looking for a cure right now, because COVID-19 is a very peculiar kind of virus. So we've had, for those of you who don't know, the coronavirus, there's no one coronavirus. There are several different coronaviruses. The one that we're being affected right now by is COVID-19. That is one particular virus. So the coronaviruses have been around for quite some time, and doctors have been doing a lot of research on it, but because of the nature of how the virus is set up, there's a lot of biochemistry involved, which may be too difficult to explain right now, but just basically the structure of the virus makes it very hard for you to kill it per se. So a lot of the work that's being done is going to be done by your own bodies, by your own immune system. So instead of trying to figure out a cure for the virus, we're looking more towards a vaccine for the virus. And there are doctors, even at the University of Miami, there are doctors in Miami, there are doctors, I think, at the University of Oxford who are working on it.
What do vaccines actually do? Like, what do vaccines do?
I'll get to that. But yeah, a lot of doctors like at Oxford and a lot of places are working on the vaccine for it. And what the vaccine basically does is, there are different types of vaccines again. So there's some vaccines who actually use dead versions of the virus. So they find a way to kill the virus in a lab. They normally heat it up or expose it to some condition that can kill the virus. And then they actually inject it with the dead virus. And what the dead virus does is that your body gets used to seeing that type of cell inside, so that when you actually get infected by a live version of the virus, your body can detect it and say, okay, I've seen this before, I know how to fight this, and that's how you fight infections. There's another type of vaccine where they actually use the living virus itself, but a very weakened version of that living virus. So it's actually, that way is normally more effective, but of course that's dangerous, because some viruses you don't want to inject into people at all, because you don't want any risk of them actually getting the virus in the process. A very famous one that's very hard to find a vaccine for right now is HIV/AIDS, because you know that's not something you want to inject into people to even test, because you don't want anybody risking having that disease. So that's the difficulty we have with finding a vaccine.
How do you get HIV?
That's a whole different topic, but all I can say to that is just practice, just have safe practices when it comes to sexual health. Assure you know what not to do. Yeah, assure you know to use protection if you're going to that sort of stuff, but I don't want to get into that. But AIDS is a sexually transmitted virus, so that's something that, you know, you get through physical activity with other people. Is there another question here?
What are some of the symptoms?
There are a lot of symptoms. One of them is called Kaposi's sarcoma, which is basically like some type of lesion, like a skin lesion that comes up on you. Drew, I don't think you need to be worrying about AIDS right now. I really hope you don't have any.
Okay.
But yeah. And yeah, you're going to have to work very hard to get into Oxford. It's not impossible. Nothing is impossible. You can get in. I have friends who have gotten into a lot of we have what you call Ivy League schools. I have a friend from Arden, actually. She was the head girl for Arden while I was head boy. She got into Dartmouth, which is a Ivy League school, which is basically like one of the top universities in the world. So it's not impossible. And I know people who have gotten into, there are people who've gotten into Harvard, people have gotten into Yale, you know, none of it, it's impossible. Yeah. I mean, William had asked, okay, like, take care of the patient. As a doctor, William, you do get to take care of the patients. It's kind of a thing now where it's a risk. Yeah. The thing is, as a doctor, you have a choice in terms of whether you want, so you have a choice in terms of either you're going to choose to be a doctor that day, which means you're going to serve everybody that comes in, no matter what disease you have, because when you choose to be a doctor, you have to serve everybody that comes into you, because you literally make an oath to say, I am try and treat everybody regardless of whatever condition. But you can choose to take a day, you can choose to take time off. I know a lot of doctors who are taking time off during COVID because they don't want to risk contracting it. But also there are a lot of doctors on the front line, doctors, nurses, and it's not just doctors involved, doctors, nurses, biomedical engineers, you know, there are a lot of engineers, especially now, that are involved in the medical field. So you don't have to go to medical school to be a doctor. There are other people involved, and they're on the front lines fighting COVID-19, trying to come up with solutions. In terms of SAT score, Daniel, I got a 1480, but I got a 1480 out of 1600. But I know the University of Miami also considers CAPE results. So if you do CAPE, they also take that into consideration. I'd say to get into UM, you'd want a score of somewhere over like 1350 and over. If you get between 1300 to 1350 out of 1600, there's still a chance for you to get in. I'd say to be safe, aim for as much as you can. Aim for the 1500s if you want to be sure to get into a college. But if you can't get to the 1500s and you miss and you get close, like me, I was close, I was barely below it. But even if you get close, you're still doing well. Anywhere within the 1400s up, that's a really good score. Excellent score. You can get into a lot of universities with that. 1300 and up, same thing. You can get into the University of Miami with that, if that answers the question. And yes, Yale does have a good program. Yes, Drew?
So does like UM have dorms and those stuff?
Yes, so I'm actually living in a dorm. This semester I'm going to be we have this thing called a first year fellow, which is basically an academic advisor that lives in with other students. So that's what I'm going to be this year. So yeah, we all live on dorms, and you also have resident assistants, which are other college students in higher year groups than you, who actually oversee you. So it is a dorm setting, and it's not like school now where you have prefects and people policing over you. In college, you're way more independent. The RAs are students like yourself. The FYFs are students. I'm a student and I'm an FYF. So obviously it's not going to be like, as serious as, you think it will be on your own for the most part. So yeah, that's how it's set up. Yeah.
Do the dorms like have roommates, like two people live in one dorm or something?
Some of them have roommates. You have the choice to live with a roommate. That's the cheaper option. You can also get your own room. You can get a single, so you don't have to live with another person. There are different setups. Every college has a different setup. University of Miami, we have singles, we have doubles. Sometimes you have
live by yourself.
Right, yeah. Right now I'm living in my own room, but yeah. It's set up differently at different colleges. That's something you'd have to look up. You can easily look up what are dorms like at different colleges if you're interested. And Daniel asked a question about Yale. Yes, Yale has. So the thing is, you'll find that when you get further in STEM, there's no one science program. Like there's no one degree that's just called science. Like there are many different programs, and like you have to choose what's the best program in each field. So Yale can be better at UM in biology, for example, but that doesn't mean it's better than UM in chemistry or
the program that you want to do and university.
exactly. So it depends on the program that you want to do. So for me, yes, Yale has a better overall science program, but University of Miami had a particular neuroscience program that I especially wanted to get into because of the particular research that they did. So that's why I chose UM. So Yale overall is a better school if you're looking on the name, but also you have to think about what you are particularly interested in. Like it's not just about the name brand, it's about what you actually want to do, like with your career. So yeah. I don't know if there's any more questions. Drew, your question them finish because I know you have a lot. But yeah, I don't know if there are any more questions. Can you get a vaccine for a virus if it mutates? That's actually a very good question. Okay, so the flu virus, so there's actually a vaccine for the flu that is very common. And the thing about it is every year we have to make a new vaccine for the flu virus because it's something that actually does mutate like very often. So what you find is, if what? Yeah, I didn't really hear that. I don't know if you can.
The flu virus evolves.
Yes, so basically, I wouldn't want to say evolve. Evolve is a broader term. Evolve is more of a long-term thing. But yes, so cells do mutate. When they mutate, all that means, for those of you who may not know, basically the cells develop a new gene and the gene changes how that cell is physically made. So sometimes you have, and this is very common with viruses multiply fast. And if a virus multiplies too fast, the chances of it mutating increases. Like if you think about it in terms of statistics, if you have, let's say, every 1 in every million of that virus mutates. If that virus has 10 million cells being born every day, that means there are 10 cells that can mutate out of that 10 million. There's a chance that 10 of those cells would mutate. And all it takes is 1 cell to mutate. And if 1 cell mutates, it can spread and grow and it's in number, which is why, like, when it comes to vaccines, we have to constantly be careful of how quickly they can mutate. That's actually something we consider. The coronavirus, COVID-19, it's actually thought that this could have been one of the earlier coronaviruses that we had, one of the ones that weren't very dangerous that actually mutated into COVID-19. We're still not exactly sure if that was the case, but that is a possibility. And it's the same thing with the flu. There's this disease called MRSA, MRSA. I believe it's MRSA. There's another one, it's called a staph infection, which is something that you can get in a hospital. And it actually is, it very commonly mutates. So like it mutates very often. And because of that, they have to constantly be coming up with new medication. For those of you, like, you can ask your parents, a lot of the medication they took back then for certain disease and certain problems, they have to change the medication. Now they use new medication, not because the old medication was bad, because a lot of these diseases are getting stronger. You have to think about the fact that these diseases, they're organisms just like us. They want to survive, so they'll do anything to survive. So as humans, and this is why STEM is so important, we have to be one step ahead of the diseases. We have to try.
So sir, they're alive?
So a virus, so it's actually a debate in science whether a virus is alive or not. What we do know is that while a virus is inside of a cell, it does show characteristics of being alive. But when it's outside,
alive, like it has a mind, like alive.
I wouldn't want to say it has a mind, but it has genes that can control how it moves, how it behaves, how it interacts. So you don't necessarily need a brain or a mind to be able to move or to be able to interact. Viruses and a lot of bacteria actually have their own genes that can cause them to behave in a certain way without having a brain per se. So it's really those genes, that actually control how they behave. And because of that, they actually show signs of being a living thing also. So these are things that evolve, mutate. These are things that we have to constantly keep up with.
Sir?
Yes.
Sir?
Yes.
Is a human a virus?
If what?
A human is a virus.
No, a human is not a virus. We are not viruses. So they're different. So biology has a classification system for every living organism. So we're all organisms, but a human is a special type of organism. We fall under the animal kingdom in terms of how biology, but we are very peculiar. Humans, we all know that humans are special organisms. So let's just say that. So humans are different from all the other organisms, but viruses on a whole. Yeah, sure. But let me answer.
So we evolved from monkeys, right, sir?
Hold on, before I answer that. So yeah, we're different from viruses. So no, we did not evolve from monkeys. The theory of evolution does not say that we evolved from monkeys, contrary to what a lot of people believe. What it says is that we may have close ancestors who were monkeys. So that's what evolution is saying. So it doesn't mean that a monkey turned into this, then to that. What evolution says is that we may have a close ancestor that was very similar to a monkey. And that's something that we can never fully know. I, for one, I am a Christian, so I personally believe my own philosophy as it relates to God creating the world. But
Yeah, me too, sir. Sir, me too.
yeah, so there's no one way of thinking about it. It's all about your choice and your perception. If you want to believe in Christian beliefs, then sure, because that's what I believe in. But just know that you don't have to believe in humans evolving from a monkey. There are many different ways, there are many different arguments for how evolution went. Some scientists even believe that evolution is something that God has control over also. So
Wait, so,
there's
sir, do scientists always basically say like there's a logical explanation for everything?
there is a logical explanation for everything, but science and spirituality and science and religion are two different things. Science deals with the logical world. Science deals with what we can physically see, touch, feel. Religion deals with what you cannot see. You can't see God. You can't necessarily, physically see him present, but that's a matter of faith. If you believe he's there, that's about your faith. Science can't test that. Science can only test things that are already physically present. So there's no issue with being a scientist and believing in God or having to worry about always thinking logically. Yes, you're thinking logically, but you're thinking logically about things you're seeing in front of you. It's almost like you're seeing this pen in front of me. I know that this pen is there. How this pen is made, I can pull it apart, I can tell all its parts, I can figure out a way to rebuild it. That's what science is concerned with. Science is not concerned with figuring out if this pen has a spirit or if this pen has a soul in it. Like, science does not concern itself with that. That's about religion. So your personal life, your religious beliefs are completely separate from your scientific beliefs, if that's what you're worrying about. But yeah. There any other questions? I believe I'm here till 12:30. So if there are any other questions, I'm free to answer until then. All right, if you have any other questions also that you want to ask me privately, you can always email me. If it's about college, I think Lenika sent it in there. Thank you very much, Lenika.
Okay, guys. So if we don't have any more questions, I guess we can wrap up. So thank you, Fabrizio Darby, for being here, for presenting and just being enlightening. It was very, very enlightening. I hope Jumaine did not tire you out with questions too much.
No, I appreciate the effort. Thank you for having me here.
Really enjoyed it.
Yeah, I really
Yeah, so
enjoyed it.
thank you for being here. And
So, sir, what kind of food do you eat?
All right, Drew.
Bye.
Bye, and I love the presentation.
Thank you.